A big question that often comes up when talking about skeletal muscles is how we can determine their actions, or what they do in other words. Follow along to learn how to analyze the various characteristics of a muscle that go into its action. Determining the action of a muscle is a multi-step process because its function is made up of the direction of its striations, its origin, insertion, and the ranges of motion of the structures around it. To dive deeper, we can look at all these aspects individually and see how they impact the action of the muscle as a whole. First, the orientation of the striations. Skeletal muscles have striations, which are essentially the pattern created by repeating units of sarcomeres. This results in the appearance of lines all going in the same direction along the length of the muscle. Because sarcomeres are the functional contractile unit of a muscle, their contraction, or shortening, is what causes the muscle to be able to pull and create movement. Thus, the direction in which the sarcomeres are oriented, or the striations, generally indicate which direction the muscle will pull. Another thing to look at would be the origin and insertion of the muscle. The origin is the attachment that remains immobile during the movement, while the insertion is the attachment point that moves from the contraction of the muscle. Identifying these points based on the range of motion of certain bones takes knowledge of skeletal anatomy, but it's crucial to know what's going to happen when the muscle contracts. For example, the biceps brachii is a common muscle used in many activities with two origins on the coracoid process and the supraglenoid tubercle of the scapula, and an insertion on the radial tuberosity. Because the two origin points are immobile within the skeleton, it can be concluded that with the shortening of the biceps brachii, the radius and therefore the forearm will be moved upwards. This results in the flexion of the elbow joint. All in all, to determine the action of a muscle, you need to analyze the direction of its striations, its origin and insertion, and locate which of its articulating structures are capable of moving. The rotator cuff is made up of four muscles: the supraspinatus, subscapularis, teres minor, and the infraspinatus, all located around the scapula. First, the supraspinatus originates on the supraspinous fossa of the scapula and inserts onto the superior facet of the greater tubercle of the humerus, allowing for the abduction of the shoulder joint. This muscle's striations are organized horizontally. Second, the subscapularis is a muscle which allows for the internal rotation of the shoulder joint, originating on the subscapular fossa and inserting on the lesser tubercle of the humerus. The striations on this muscle range, with the superior section being striated almost horizontally, while the inferior portion of the muscle is striated diagonally, pointing upwards on the lateral side. The third muscle making up the rotator cuff is the teres minor. This muscle originates on the lateral border of the scapula and inserts onto the interior facet of the greater tubercle on the humerus, allowing the shoulder joint to externally rotate. The striations of this muscle are at a steep upward diagonal angle going up laterally. Lastly, the largest muscle in this group is the infraspinatus, which originates on the infraspinous fossa of the scapula and inserts onto the greater tubercle of the humerus. This muscle allows the shoulder joint to externally rotate. The striations on this muscle are oriented diagonally, going up laterally, but less steep than on the teres minor. To reiterate, this table encompasses basically all the information that I went over in this video, including all the actions, origins, insertions, and striation directions of the muscles that make up the rotator cuff. All of these muscles contribute to the movement of the shoulder and arm, which make up the shoulder joint in general. Yeah, and thank you for watching. I hope you learned something.